Hello everyone and welcome to this section. This section we're going to take our just one neuron model that we had before, or the perceptron model that we had before, to actually take it to the kind of a next level to build multi-layer perceptron network, okay? So I actually showed you that before, but if you guys go to the playground, the TensorFlow, you can actually go there and try to change, for example, the number of hidden layers, number of neurons, and that's what we're going to be doing in this section. We're going to add, again, different hidden layers. We're going to add different neurons. We're going to change, for example, the activation functions from sigmoid to like ReLU or whatever. And then we can use it to actually classify more advanced data sets. All right. Again, I urge you guys to go there. We have done it before. This is just kind of, a refresher of what we have done and how we actually train it and get an idea of how we train our model. Okay. All right. So let's, again, take our network, which is, again, single neuron network. Okay, that's one neuron. And let's build what we call it the two neuron network, or two neuron model. Again, step by step, let's go and see how can we build the entire network. So as you guys can see here, this is one neuron. So we have a bunch of inputs, P1, P2, P3. We have a series of weights, weight 1, weight 2, weight 3. We knew right now that we can multiply the inputs by the weights, add a bias signal, and that will generate, let's say, signal, let's say A1, okay? And then, that will generate N1, which is this value, which is N1. We'll apply an activation function F, that will generate our, let's say, A1, or we call it Y, or we'll call it whatever. Okay, that's the first neuron. Okay, let's get another neuron. That's another neuron. It's exactly the same. Okay, we use the exact same input, P1, P2, P3. And we have, the output gonna be A2, all right? So these are kind of two neurons like separately, right? What we wanna do, then we're actually gonna combine them together and build our first kind of, two neuron model, okay? So since the inputs are common, so P1, P2, P3 are common, if we combine them somehow, actually we're gonna generate this kind of, the two neuron model. So the input P1 will actually be sent to the first neuron and the second neuron. And the weight value, that's very important. It's what we call it weight 1, which is weight that's going from the first input to the first neuron. And then we have what we call it weight 2, okay, which is weight that's going from the first input 1 to the second neuron 2, okay? And then the next step is we're gonna call it P2, which is simply, again, we read it kind of, in a reversed fashion, all right? So we have P2, okay, going again to the first neuron, and we have 2 going to 2. And then here we have 3, okay, going to 1, all right? So we have input 3 going to 1, which is weight 1, 3. And then we have weight 2, 3, all right? And then we have a bias. We have bias 1 and bias 2. We apply again activation functions, generate A1 and A2. So in very simple form, okay, in order to draw, all this like network, what we're going to do instead, we're just going to represent everything in a matrix form. And that's the beauty of it. We can actually just boil down the entire network to become just a couple of weights that tell us exactly how can we train it. We can apply different, more advanced training algorithms moving forward. And that's pretty much the matrix representation of our network, of our neural network. So if our neural network in this case, okay, first of all has 8 adjustable parameters. Why? Because we have 3 weights for the first neuron, 3 weights for the second neuron. So we have in total, we have 6 weights, right? And we have 2 bias signal. Okay, that's again, if you count them, again, it's very simple. 1, 2, 3, 4, 5, and 6. That's 6 weights here. And we have 2 biases that will sum up with 8 adjustable values. So now we can have simply 2 matrices. We can represent the entire matrix, the entire network in 2 matrices. Matrices of biases to B1 and B2. And we have matrices of weights. So we have weight 1, weight 1, 2, weight 1, 3, 2, 1, 2, 2, 2, 3. And then we can simply perform like a matrix multiplication. Multiply the weights by the inputs, okay? Add the bias signal, apply an activation function F, you're good to go. That's it. That's how you represent a 2 neuron model in a matrix representation form. All right. So now we're good. We went from 1 neuron to 2 neuron. Let's take it to the next step. Let's actually build the multi-layer perceptron network. That's pretty much what we have here. So we have our input layer. We have our different hidden layers. We can have as many hidden layers as you want, okay? And again, the multi-layer perceptron network consists of 1 input layer, hidden layer, and 1 output layer. And again, all the inputs propagates through the network to generate our output, all right? Okay, so let's take a look at a little bit of math for the multi-layer perceptron network. So as you guys can see, if we pick any of these neurons, again, you will see a bunch of inputs going to our neuron. So we have, let's say, x1, x2, x3, for example, multiplied by a set of weights for this neuron. The neuron will generate an output, okay, x. Okay, and again, I don't want to dig into all, because we're not going to be doing any of that math. Again, I'm just going to give you the intuition of what it is. Like, how can we boil that network down to just, a couple of matrices. So here we simply multiply all the weights, okay, by the inputs x in any neuron. If you pick any neuron, we have inputs, we have weights, multiply them together, apply an activation function here. This is our activation function to generate simply the x, which is going to be the input to the next layer, all right? And that's why here you will see there's n+1, which is, that for the next layer represent until we generate the actual output from the network, okay? Activation function here, we assume it's sigmoid function, for example, so it's 1 divided by 1 plus e power minus the input, and that's kind of the nonlinear sigmoid function. All right, so let's take a look at the matrix representation then. That's pretty much the matrix representation. We have a couple of inputs, P1 up till Pn1, which is the number of inputs that we have. And then we have a couple of weights. So we have series of weights. So if we have weight 1, 1, weight 1, 2, and so on, that's how we kind of build our matrix. And that's how can we use it for backpropagation or for any training algorithms to actually train our network, okay? All right, and you guys can go to this, check out this like research paper. It can shows you all the, how can you build an actual artificial neural network. And that's where the image is actually from. And if you guys can see here, that's again m small, that's the number of neurons for the hidden layer, and n1, that's number of inputs, okay? All right, that's how can we build from a single neuron model to a 2-neuron model, and then to a multi-layer perceptron neuron model, okay? What we're gonna do now, we're gonna actually use all that learning in Python and in the Jupyter Notebook to actually build our multi-layer perceptron network, all right? That's all what I have for this section. I hope you guys enjoyed it, and see you in the next one.